This is the Algebra 1 Summer School Unit 7 Lesson 1 Notes video. Today, this is the unit on mixed modeling. We're going to be doing linear modeling, exponential modeling, and quadratic modeling. We've looked at all of those functions throughout this course. Today, we're going to put those all in application. Excuse me. Lesson 1 is all about linear modeling and interpreting linear models. In order to be successful with working with linear models, we have to talk about the equation of a line, which is written in slope-intercept form. Y equals mx plus b. In that form, m is the slope. The slope, when you're looking at a graph, is the rise over run of the graph. And with an equation that we can use to find the slope is y2 minus y1 over x2 minus x1. In the slope-intercept form, the b is the y-intercept of the graph. Let's review really quickly slope-intercept form given graphs. How do we write the equation from a graph? We always start with b, the y-intercept. And here it appears that b is -1. And the slope, my rise over run, I'm trying to get between two nice points, is up 1 over 2. So 1 over 2. When I write this equation, I'm going to write it as y equals m, which is 1/2 x plus b, which is -1. So I'm going to, instead of +1, I'm going to do -1. That's your equation. For this graph over here, I start with my y-intercept at 3. And to get between these 2 points, I'm going to go down 3 over 3. Well, -3 over 3, that equals -1. So when I write the equation here, I have y equals -1x plus 3. One other thing to remember about y-intercepts is it helps us a lot, that will help us a lot in this unit, is that the x value of a y-intercept is always 0. For example, up in the second graph here, that y-intercept we said was 3, but the ordered pair for that point is 0, 3. The x value is always 0. In linear modeling, we also like to refer to the y-intercept as the starting value. All right. In math situations, we say that the independent variable is represented by the letter x and the dependent variable by the letter y. So that just means when we write an equation for a line in y equals mx plus b form, it means that the y value is going to change. It depends on what you put into the function for x. So let's look at this first problem here. This is a graph that represents the cost of buying a certain number of pool passes. So the first question says, how much does it cost to buy 8 passes? Well, on the x-axis here is our number of passes. So I'm going to look at 8. If I go all the way up to the graph and then read over, it looks like it's going to cost $30 to buy 8 passes. Now if I look the other way, now it says, well, how many passes did you buy if you spent 12? On the cost axis, I go over to the graph, look down, and it looks like I bought 2 passes for that amount of money. Now this graph is asking for the y-intercept. Well, the y-intercept is an ordered pair, appears to be at 0, 6. They want us to interpret in context what that y-intercept means. Now, when they ask you to interpret something in context, that means you need to talk about the number of pool passes and the cost of pool passes. Well, 0 is the x value. 0 means that you had bought 0 pool passes. So 0 pool passes cost $6. That's where the 6 from that y value comes from. So it costs you $6 even if you buy no pool passes. Now let's talk about the slope of the line. Remember, slope is rise over run. So I'm going to start on my y-intercept, and I'm going to pick another nice point on my graph to help me find the rise over run. Well, here, when I rise up, it is only rising up 1 square, but the unit here from 6 to 12 goes up 6. So the rise is 6, and I'm going up, the unit is $6, and I'm running over one box, but that one box is worth two pool passes. So $6 per 2 pool passes. Another way we can write that, we can simplify 6 over 2 to be $3 over one pass. In context down here, that means that you pay $3 for one pool pass, or $3 per pool pass. Well, now I know the slope. We already identified that this slope was 3, right? $3, and the y-intercept is 6. So since I know the slope and I know the y-intercept, I can write an equation. Now, all of our equations are always going to be in slope-intercept form. We can use y and x, and if you like to use y and x, that's completely fine. Here they want to represent the cost c, so I'm going to use c instead of y. The slope is 3, and it says p is the number of pool passes. P plus 6. Again, you could have written that. That's the same as y equals 3x plus 6. But a lot of times in word problems, we like to use different letters so that we can say the cost is 3p for pool pass plus 6. All right, let's try a different example. The second one is called the bathtub. Billy Bob has an ancient bathtub that drains slower than the Dickens. He filled up his tub and then let the water drain out to see how long it would take to drain. The graph below represents the number of gallons of water remaining in the tub and the time in minutes. Okay. So it says how many gallons are in the tub after 6 minutes. Well, this x-axis here represents minutes. So if I look at 6, I go up to the graph, and it looks like there are 12 gallons in the tub after 6 minutes. Now the next question asks if there are still 4 gallons left. So I go to 4 for gallons. How many minutes has the tub been draining? Well, it looks like that would be 12 minutes. Now it asks me, what's the y-intercept of this graph? When I look at the graph, I'm going to go all the way up to 0, 20. Now remember, 0 is on the x-axis, which is talking about minutes. So that means after 0 minutes of draining, the tub has 20 gallons of water in it. Okay. Now let's find the slope. Notice that the line is negative. It's going down. So your slope is going to be negative. Let's make sure we write a negative there. Now 2 points that I'm going to use. I'll start with the y-intercept, and then this looks like another nice point to go by. So I'm going to do my rise. I always go up and down first. So I'm going to go down, and this time 2 boxes from 20 to 16 is going down 4. So -4 gallons, that's the scale on the rise, over 3 boxes, which is 3 minutes. -4 over 3 cannot simplify. So in context, what this means is the tub drains, so it loses 4 gallons of water every 3 minutes. Well, now that I know the slope and I know the y-intercept, I'm going to write an equation in slope-intercept form. Okay, so we're going to talk about the number of gallons, G, equals, we said the slope was -4 over 3. Instead of x, they want us to use m for minutes because minutes is on the x-axis. And the starting value was 12, or not 12, plus 20. So the equation, that's here, you can always check, has a y-intercept of 20, and you're going down 4 over 3 every time in order to graph your line. That looks correct, so we're all set to go. All right, let's check out another one. Example 3. It says the equation C equals 2h plus 5 represents how much it costs to park your car in the North Gate parking lot based on how many hours you have your car parked there. First of all, it says state the y-intercept. Well, this equation is in y equals mx plus b form, and this b is the y-intercept. That constant up there, 5, is also the y-intercept of the equation, even though there's not a y and there's not an x. Well, it says, what does that 5 mean? Interpret in context. Well, it seems to be, let's see, we're talking about how much it costs to park your car. Well, remember that the y-intercept always happens when x equals 0. So the x, that's like our h for time. Well, if time was 0, the y-intercept would be 5. So that means you pay $5 to park even if you stay 0 hours. Oops. Now what that means is in the real world, that's like a flat fee. So you have to pay $5 in general to go into the parking garage, and then you pay an extra amount of money on top of it. Now it's asking us for the slope. The slope is the number in front of the independent variable. So here the slope is 2, and what that means is you're going to end up paying $2 an hour. It costs $2 an hour to park. So you pay $5 when you go in, and you have to pay $2 every hour that you're there. Now, how much money does it cost to park your car for 3.5 hours? If I'm told 3.5 hours, that means you're going to put 3.5 into the equation for h. So cost equals 2 times 3.5 plus 5. When I simplify that, that's 2 times 3.5 is 7 plus 5, which is $12. So you're going to pay $12 if you park your car for 3.5 hours. Now this next problem you have to read carefully. If you pay $95, how long did you park your car? So this time I'm looking for h. I know that I paid $95, so I'm going to put in the equation c equals 2h plus 5. I'm going to put 95 in for c. So I'm going to 95 equals 2h plus 5. I'm going to solve this equation like we're really good at by now and get 90 equals 2h. Divide by 2, and I end up with h equals 45 hours. So if I paid $95 to park, that means my car was there for almost 2 days for 45 hours. All right, last question. This is an OST linear modeling question. It says that a shipping company charges a cost per pound plus a fixed fee to ship a package. The total cost, f of x in dollars, of shipping x pounds is modeled by the function 4.99x plus 5.75. All it says is what part of the function represents the fixed fee. Now let's go back to what it says first. It says that they charge a cost per pound plus a fixed fee. The cost per pound, anytime you see that word per, that's going to mean slope. So the cost per pound is always the slope. And the slope in this equation is 4.99. So that means they're charging you $4.99 per pound. The fixed fee, that's always where you start. That's your y-intercept every single time. So that's always going to be the 5.75. So for this shipping company, you pay $5.75 flat fee, and then $4.99 to ship a package per pound. All right, those are your notes for linear modeling. It's a really good idea to try the practice that goes along with this lesson. Check out the key that's posted on Canvas, as well as watch the practice video.